Hi guys, so we're just going to have a bit of a chat about linear models. We've talked about slope, we've talked about y-intercepts, and we've talked about applications of slope and y-intercepts. However, we can also interpret and apply and model a whole lot of different situations using linear models. And this is just, you can probably do these questions using the information we've done beforehand, but we're just going to go through an example of linear modelling. So one of the important relations we often talk about with linear models, and it's not the only one, but one of the important ones we often talk about is the relationship between distance travelled and time taken. So if an object's travelling at a constant speed and you have a certain time, so say it's 40 metres per second, and you're travelling for 5 seconds, then you know you've travelled 200 metres. What did you do? You did 40 times 5. So we could just simply model that situation by saying, well, distance is going to equal 40 times the time. That's all this linear modelling thing is. It's using the fact that we've got a linear model now, we've got a relationship between two different variables only raised to the power of 1. So we've got a very simple example of that here. We've got a car travelling at 40 kilometres an hour, not 40 metres per second. And again, the relationship will just be that the distance travelled equals 40 times the time. Centimetres? Let's go into a bit more of a detailed example. So a train is moving at 50 kilometres an hour in a straight line away from the town. Give a rule for the distance from the town at t hours after leaving the town. So I'm just going to say A. I'm going to go, well, the distance is just going to be 50 kilometres per hour, 50 times the time. And then we've got our train stopping at a siding that's 80 kilometres from the town, and then moving at 40 kilometres an hour in a straight line away from the siding towards the town. Give a rule for the distance D2. So this one was D1. D2, well, because we're starting 80 kilometres away from the town, we start at 80. And then we're moving at 40 per hour, so it's going to be 40t. Okay, so D2 is going to be 80 plus 40t. And then C, on a separate sketch of axes, it just says to draw the graph of those. You can quickly sketch those up. It says to state the gradient of each graph. Well, let's think about this in slope-intercept form. Y equals mx plus c. The gradient of this graph is obviously going to be 0. Slope is going to equal 0. Of this graph, however, we've got 80 plus 40t, so the slope is the number in front of the other variable. So it's going to be 40. The slope in this case is going to be 40. The y-intercept in this case is going to be 80. Okay, and so we can easily graph that. So I hope that helps you with these questions. Just basically think, what is the thing that is constant? What is the variables in this case? So if you've been given the time, and the time's the thing that's changing, that's going to be one of the variables. If you're finding distance, that's going to be the other variable. And if you've got a constant speed, that's obviously going to be the constant value on the slope generally. If you're starting at a point that's a bit further on and then you're moving off, you're going to have a y-intercept, which is that point where you're starting at. And this, of course, can be in different scenarios. So you could have a scenario of plant growth. And say you had a scenario of plant growth, and so you have your plant here, and it's growing at 2 centimetres per second. It starts off maybe at an initial height of 10 centimetres. Okay, when you got it, it starts off at an initial height of 10 centimetres. So how would you model its height? It's not going to grow at 2 centimetres per second. Say it's going to grow at 2 centimetres per week. Okay, so we're going to change that to week. So it's growing at 2 centimetres per week. So how are you going to model that? Well, your height is going to equal starting at 10, and then you're growing at 2 centimetres per week. And you just put where W is the time in weeks. And as long as you have that stipulation of what your variable represents, then you'll be able to find that. Now, when you've got these equations, you can then work out when they meet up, and so you can actually find out values, which will be more in simultaneous equations, which we'll talk about later. Hope that helps.